Hello, everybody, and welcome to episode 92 of I Wish You Were Dead, a podcast about things that used to be alive. My name is Mike, and that is Gavin. And Gavin, I think I'm owed at least a little bit of credit for something.
You are?
I am. So, and I wanted to bring this
Okay.
up last week, but in the excitement of me being back on the podcast, I had forgotten. Do you remember at some point, I don't know, maybe it was a year ago, a little more, a little less. I think it was a little bit under a year ago. And I said something about how I don't think the Queen is going to make it through next year.
I don't remember you saying that.
I totally said, because there was a thing where she was like not going to make any public appearances until February or something, and I said, this sounds like someone that's just not long for this world. And you don't remember this?
I sure don't, buddy.
Dude, well, mark it down that I was correct.
Okay, I will. I barely remember anything, so it's Google Calendar is my best friend.
Well, you can mark it down on the calendar that the Queen is dead. And so fun story about the Queen being dead. It was one of the craziest moments of my life. So for those of you that don't know, because it's been a little while since I was a regular on the podcast, and I'm a teacher, it's my day job. And this year I'm teaching an event called class called Current Events.
Sure.
And on the very first current events class that I've ever taught, first class, where the Queen was sick, and we were discussing it in class. Okay. And we're like, yeah, this usually means she's going to die pretty soon. And this one kid in the corner, which is like, you don't know that. You don't know she's going to die. You're not a doctor. Who do you think you are? And I'm like, no, like this is what happens when someone's about to die. This is all code. 30 minutes later,
she's 92.
Well, yeah. And isn't she older than that?
I thought it was 92.
I don't know. Who cares how old she's dead now?
I don't know. Somewhere early to mid 90s.
I don't know. However old the dirt is now is how old she is. So, but a half hour later, after this interaction takes place, this other girl gets a text on her phone from her mom. Queen just croaked. During class, I killed the Queen. During my current events class. It was awesome. It was incredible.
Oh my! This is not how I thought this episode was going to start.
Oh, it's the great way for our episode to start. So, all apologies to our British. Have we had British guests on?
We've had an Irish guest. She currently lives in the boundaries of the United Kingdom, but she is Irish.
Was that Dr. Dunn?
Yes, Dr. Emma Dunn.
It was so Dr. Emma Dunn. So, Dr. Emma Dunn, if you either all apologies or congratulations, depending on how you feel about the Queen, but it's my fault. And that's how we're starting this podcast.
All right. Well, with that out of the way, Sophia is going to be off for a couple weeks. She is right in the middle of her, getting her thesis things done. So we're giving her all the time and space she needs to be able to, get her education done.
A well-deserved break.
Exactly. So before we get into any of our main topics today, which are volcanoes, which is interesting. This is going to be a really interesting topic. It's a big topic, a big explosive topic, potentially. Next week, we have a wonderful guest episode because we're going to be talking about the Adirondack Mountains.
Which I'm extra excited about.
Yeah, Mike spent, if you have not listened to the past, 3-4 months of podcast, Mike spent basically the entire summer in and around the Adirondack Mountains. And coincidentally, one of my former professors at SUNY Cortland is, one of the main geologists, studying the Adirondacks and stuff. So we're going to have him on as a guest next week, and it's going to be a really fun episode. I'm really looking forward to it. So it's going to be next week. Feel free to submit any questions or comments or things you might have about the Adirondack Mountains, or even just what are the Adirondack Mountains.
And I'm looking forward to this, just like it being one of the few episodes where I feel like I might be able to actually contribute something of,
especially
of actual substance.
Yeah, at this point, you've seen more of the Adirondacks than I have. I've been to I've been to a good bit of the Adirondacks, but not really much around the high peaks. So yeah, you've definitely seen more of it than I have at this point.
So that's going to be a real fun one to do. That's going to be coming out next Wednesday, 1 week from today.
Absolutely. And in the meantime, do not forget to rate the show on whatever platform you listen to us on, including now, newly, Stitcher. My wife, Liz, informed me that because Stitcher is her main podcast platform, and we weren't on it. And she just happened to bring this up to me, granted, a couple weeks ago. But, Stitcher's weird. Getting your podcast on Stitcher's a little strange, but we are on it now. So make sure to rate us in whatever fashion, whatever platform you use to listen to us on. Make sure to follow us on our Twitter, Facebook, and YouTube, which are all linked down in the show notes. Make sure to give us feedback on the show. If you have any future topics that you'd like to suggest, we have a Google form down for that, down in the show notes as well. Or you can tweet at us. You can mention it in any YouTube comments. And if you'd like to be a guest or have a guest in mind that you would like to appear on the show, we also have a guest form down in the show notes as well.
Yeah, do all that stuff.
So, Mike, have you got a Today in History for us?
I do have a Today in History. This is something that I think I had heard of before, but completely forgot. So, Today in History, September 21st, 1897. New York runs the New York... what was it? The Sun was a newspaper in New York City, and they published an article titled "Is There a Santa Claus?" And it's more famously known by one of the. It's more famously known by one of the lines in there. Yes, Virginia, there is a Santa Claus, and there was an 8-year-old girl named Virginia O'Hanlon that wrote a letter into the editor asking, "Is Santa Claus real?" And this editorial was published. With the famous line, "Yes, Virginia, there is a Santa Claus," to help assuage any concerns that this 8-year-old girl may have had about the existence of Santa Claus. And I just think this is kind of a nice thing that can be done for small children, and also the same kinds of questions that our 8-year-olds are asking nowadays, going back over a century. What's old is new again, and so that is as I was kind of searching through here, September 21st was kind of dull for the most part, and then I kind of saw this headline. I was like, "Oh, this is a fun little story." So yeah, yes, Virginia, there is a Santa Claus. Published September 21st, 1897.
I was gonna comment that I'm like, well, September is a strange time of year to be writing letters about Santa Claus, but I guess back in the day,
I agree.
If the girl wrote a letter back around December, it probably took until September to get to wherever it was going. So, anyway, thank you for that wonderful Today in History, Mike.
So, yeah, you seemed a little bit concerned as to where this was going, but no, it's good.
Oh, I was very. I mean,
I have a history with this kind of thing.
I didn't want to say it myself.
Yeah, I'm assuming we don't want to tell the full story here, but I have a history with this kind of thing not going well.
Listen to the Antarctica episode if you haven't. Anyway. So, on to our main topic today, volcanoes.
I am super looking forward to this.
Yeah, they're some of Earth's coolest features, which is incredibly ironic because they're very hot.
But tis. Very nice, guy. So, very nice.
It seems to be kind of weird to describe what a volcano is, because it is one of the most ubiquitous things, especially when in the field of geology, where it's a rock is very nondescript. Everybody knows what a rock is. Volcanoes are very descript, but everybody still knows what one generally is.
Is this the kind of thing where, there are some very obvious cases of volcanoes, but there's some edge cases where it's depending on whose definition you use, you may or may not have a volcano versus just magma? Or is there a pretty clear-cut definition as to what makes a volcano?
So it's kind of the opposite, where it's there's a very broad definition, but because most people only think of a very narrow section of it. So
okay.
But before we get into any of the technical stuff, I just want to point out that you and I, for example, have been extremely lucky that there have not really been that many major, impactful eruptions in our lifetimes.
Right.
So we were both born in the mid-90s, and the biggest one in that time happened just this year, back in January of 2022, when the volcano over in Tonga in the South Pacific erupted.
Was this the one that you could see from space?
Yes. This was the biggest volcano, biggest eruption of so far the 21st century, and has been the biggest volcano since 1991, and we'll talk about that one for sure. But yeah, so the volcano itself was called Hungatunga Hunga Hapai, I believe, in some Pacific Islander language. I don't know if it's Tonganese or whatever language they speak in that part of the world. And so this was Tonga is a very small country. It's a chain of islands in the South Pacific. And when it erupted, like I said, this was, I think, January 15th of 2022. And so I was still living in California at the time. And even though, South Pacific, California, not particularly close to each other, but I got many very urgent, like, emergency text messages from, like, the California government, basically being like, do not go in the water right now. Because,
really?
Yeah. So, because this was an underwater eruption, especially, these alerts were basically for potential tsunami activity, even all the way in California. They were like, do not go in the water. And there was even reported tsunamis. Granted, it's not quite what you think of as a tsunami, but a town a little bit north of me reported extra 4 feet and some change of wave activity. So like that, not nothing, but even places.
That's kind of huge thinking about in the context of
how far away
the
that
normal
is.
tides, right? How far away the explosion is, or the actual volcanic explosion, but also just like what's a typical tide, like the difference between a high tide and low tide.
I mean, it really depends where you are, but it can be a good 20 feet probably.
Oh, really? Okay. Okay, that is far more than I would have thought just for tide. So 4 feet.
Granted, that is me sort of spitballing. I don't actually know.
Okay. So 4 feet is still significant, not earth changing by any means, but that's
right.
Notable.
Yeah, but some other big eruptions that, for example, our parents probably would remember quite clearly is the Mount St. Helens eruption in 1980.
That's the one that came to mind.
Very big, and we'll talk a little more in detail about how big that one in particular was. However, so that was in 1980, and then 11 years later, the second largest eruption of the century, so of the 1900s, happened in 1991 when Mount Pinatubo in the Philippines erupted. Enormous eruption. And so we'll talk exactly about how we sort of classify how big different eruptions are a little bit later in the show. But first,
okay,
what is a volcano? What is the actual definition? So, like I said, it's very broad. And so it is just a vent at the surface of the earth that molten rock comes out of, and also typically various gases and chunks of solid rock as well. But the molten rock has to be a component. And so that can literally just be a hole that some magma oozes out of. Just for clarification, it is magma when it is underground. As soon as it comes above ground, it is lava. That's the.
Is there any chemical change there, or is it the exact same
no.
substance? Just okay.
Yeah. I mean, it's the difference between, well, no, I was going to say ice and water, but that's not really true. It's basically, if you have, well, we've talked actually about how ice is a mineral, so groundwater is technically lava. Anyway, I don't want to go down, or magma. I don't want to go down that rabbit hole. But yeah, the only difference between,
I was going to compare it to,
yeah.
No,
go ahead.
I was going to compare it to, like, you go to a bar and you ask for a Bat Light, and they're like, do you want it in a can or do you want it on draft? It's the same substance, but just like, two different vessels for it.
Yes and no, because magma, becomes lava when it comes out of, when it comes above the surface of the earth.
Yeah, that transitory state's what got me on that metaphor. I really tried, though.
You did, and I appreciate it.
I appreciate it.
Yeah, that's the only distinction between lava and magma. So just know magma, underground, lava, above ground. So that's all a volcano is. Just a hole that molten rock comes out of. That's it. Doesn't have to be a big mountain. Doesn't have to be explosive. Doesn't have to be any of that. But that's typically what people think of when they think of a volcano. And especially like mountains. Mountains, especially because mountains tend to be the explodey ones, but they don't really have to be mountains. For example, volcanic fields are not uncommon, which is basically just an area where at any point, bits of, molten rock can just kind of come out of pretty much anywhere within a given area. So because it's not constantly erupting in the same place, it doesn't build a mountain or anything. And it could be anywhere from that flat field to a giant mountain and any variation of shapes in between.
Okay.
And a little more background on volcanoes themselves. So way back, I thought this episode was much more recent than it actually was, but in episode 39, we talked about plate tectonics and how plate tectonics is the main driver for pretty much...
Wow.
Right? But yeah, so plate tectonics is the main driver for most large-scale things you think of on Earth. Plate tectonics is in large part why we have glaciers on Antarctica right now. Plate tectonics is, responsible for, I'm going to say at least like 98, 99% of volcanoes as well. And we'll talk about some of the exceptions in a little bit. But plate tectonics is a major feature. And as the plates move around, some of them have to sink. If you have two things bumping into each other, they're either just going to keep going until they crush each other completely, or one of them's going to give way and sort of sink down below the other one. Typically with tectonic plates, the one that is more dense will be the one that sinks, and that's usually ocean crust, just because it's made out of different types of rock, and ocean crust rocks, basalt, tend to be more dense, and so they'll sink underneath the less dense continental rocks. And so when they sink, the core of the planet is really hot. So as they sink down closer, that rock melts. And then molten rock rises back toward the surface as magma, where it will find
it's a cycle,
way...
Right?
Yeah, it's right. It's a cycle. And we also had an episode about the rock cycle, but I don't have that episode handy off the top of my head. So moving on.
It exists. You can look it up.
It does. So plate tectonics is everything when it comes to volcanoes. And that's, for example, why we see lots of volcanoes around plate boundaries. Especially convergent plate boundaries where there are two plates moving toward each other, or divergent plate boundaries where there are two plates moving away from each other. Not so much the transform boundaries where they're sort of sliding past each other. That's why there's not a lot of active volcanoes, for example, around Southern California, because that's where there's the San Andreas fault is a transform fault where it's just sort of sliding laterally past each other.
Right.
Whereas in places like the Pacific Northwest, where there's lots of volcanoes, that is a convergent plate boundary. So a plate is sinking, it melts, and then rises back up to give us volcanoes like Mount St. Helens, Mount Rainier, etc. Other places, like I said, where plates are moving apart at divergent plate boundaries, you get mid-ocean ridges, which is just a fancy name for a gigantic chain of volcanic mountains underwater. For example, all the way down the center of the Atlantic Ocean, like basically from the North Pole down to where Antarctica is, there's a giant, it looks like a seam running down the middle of the Atlantic Ocean. That is just a giant chain of volcanic islands, because that is where the Americas are moving away from Europe and Africa. And as they're moving away, when the plates move away from each other, magma has to come up and fill that newly created gap.
And I'm imagining this is kind of where you were talking about how the definition, the scientific definition, is far broader than just what the general public thinks. Because I don't think the general public is just thinking of, ocean floor vents that happen to exist, in the middle of an ocean. They're thinking of, the more, cone-shaped things that are on land. But these are volcanoes in the middle of an ocean, just like the ocean floor spreading apart.
Oh yeah.
Yes, I mean that's that's definitely not what the general public thinks of as a volcano.
Right, and I think the big one, at least in our cultural mind here in North America, is volcanoes like Mount St. Helens, because that was by far the most economically costly eruption in U.S. history.
Right.
It was extremely destructive. Luckily, relatively few people died. I think it was less than around 50 people died. But as we'll talk about, given how big of an eruption that actually was, that's good job on all the, evacuators and people.
Right.
But yeah, so or volcanoes also play a really interesting part in all of the various cycling of pretty much everything on the planet. Like you said, it's a big cycle. And so how volcanoes sort of work into that is the stuff, rocks and otherwise, because other stuff that's, on the rocks, different gases that are trapped within the rocks, things like that, when they get sucked down into the core of the earth or the center of the earth to get melted again and then come back up. When they come back up, they have to go through volcanoes. That's pretty much the only way to get back to the surface. And so all of the different elemental cycles, so the carbon cycle, the oxygen cycle, the nitrogen cycle, are all really heavily affected by volcanic activity. Every element that is relevant to life needs volcanoes to renew the supply. So that is the general gist of volcanoes. Let's talk about a little more specific here. If you were to take sort of a Geology 101 class, you would typically learn about the three main types of volcanoes. Way more complicated than that. There's way more than 3 different types, but we only have, give or take, an hour on this podcast. So the 3 you will mostly learn about are called, the first one is called stratovolcanoes. And that is, some common examples are things like Mount Rainier in the Pacific Northwest, Mount Pinatubo, that giant eruption back in 1991, and Mount Fuji, which is one of the more famous ones from Japan. It's the one that you see Godzilla marching around a lot. And so these are formed by different layers of volcanic rock and then volcanic ash. Because when volcanoes erupt, obviously the lava comes out, but also there are other stuff that comes out. Ash, depending on how explosive they are, they can shoot giant blobs of lava that then cools in the air and then lands as a solid rock. Those are called volcanic bombs. And so these stratovolcanoes, awesome. they're and they can be enormous. So these stratovolcanoes are alternating layers of, cooled lava, cooled into igneous rocks, and then a layer of ash, and then more igneous rocks, and then ash. So it's sort of like a layer cake, almost.
That's a fun way to put it.
Yeah. The next one are called shield volcanoes, and they're called this because they're very dome-like. They're very large in diameter and less like a cone, like you typically think of like a mountain or especially a volcano. So these are just, and they don't have much of the ash. The volcanoes that form these don't have as much of the ash content. It's mostly just the flowy lavas. A lot of the volcanoes in Hawaii, where you see they don't really, Hawaii isn't exploding, doesn't have the right kind of lava for that. So the lava in Hawaii is very oozy. So instead of being thrown everywhere, it just sort of builds up in the central area and out. So it'll build a big dome sort of shape as it just sort of oozes from the vent out.
Yeah, so this is a slow trickle instead of a massive burst.
Exactly. So this is, like I said, most of the Hawaiian volcanoes, a lot of volcanoes in Iceland. Iceland is very volcanically active. Also, a lot of the volcanoes in the Galapagos, those are also volcanic islands. And the last one is, they're called cinder cones. And these are mostly made of I have in my notes, crumbly bits that are sort of spat out during the eruptions. So these are some of the more explosive, less flowy ones. But it might just be that they throw up bits without throwing them very far. So they'll throw them sort of up, and then they'll cool as just these little chunks of rock that over time, just this giant pile of rocks builds up into a cinder cone. The most famous one that I can find, these are not particularly common, but the most famous one that I could find was called Paricutin down in Mexico. And the reason why that one's famous is because it grew in the middle of a cornfield in 1943. Yeah, 1943. And then in a span of about 24 hours, it grew about 150 feet tall.
That seems rather significant.
Yeah. So from a flat cornfield where like there'd been some like rumbles and stuff underground. Apparently some of like the local people around there had reported hearing thunder, but there being no clouds in the sky for like a good few days beforehand. And then they just wake up and there's a 150-foot tall mountain in the middle of this guy's cornfield.
That's just not right.
So, no. And so those are sort of the main three. If you like I said, take an intro geology class, those are the ones that you'll have on the quiz. But there are another type of volcanoes that I want to do a little bit of setup for. So there are these things called hotspots, right? So hotspots are, I said earlier, 99% of volcanoes are like directly due to plate tectonics. Hotspots are the 1% that aren't directly caused by it.
Okay. So hotspots. So I guess that begs the question: what is a hotspot?
Yeah. So something funky. We're not entirely sure what makes them form, but something deep, very, very deep within the Earth's core causes a certain area to melt more than the surrounding rock and rise to the surface. So it basically creates a steady stream of magma going to the surface in a one particular spot. However, when the tectonic plate that's over top of it, when it moves, the plate moves, but the hotspot stays in the same place. So that will give you a chain of volcanoes. The most prominent sort of example of this is Hawaii.
I was going to ask. I thought that like a lot of those Pacific islands were something similar to this.
Mostly Hawaii.
Okay.
Hawaii is by far the most famous. That's why the Hawaiian Islands are in a line, more or less. And if you look at sort of a map of the underwater islands, because there are dozens of former Hawaiian islands that are now just underwater completely because they've eroded. But they basically stretch from where Hawaii is now basically all the way up to the Arctic. Because that's how long that hotspot's been there. Yeah. And it's really neat. You can actually use that as sort of a reference for how quickly the Pacific plate moves. Because if you can...
Right. Okay.
Yeah, volcanic rocks are really good at getting like radiometric dates off of. So using like different levels of uranium or other radioactive elements in them, you can get a very precise date of, when this magma was erupted. And so based on that, you can sort of figure out, well, we know the hotspot has been here, and now this underwater island is way over here. How long did it take to get there? So it's a really neat way to, in real time, prove plate tectonics. But this is, like I said, a segue, because while Hawaii is probably the most famous hotspot that we have today, it is not the only one, because the other most famous hotspot is Yellowstone. And this segues into a conversation about supervolcanoes.
Okay. Is that a real thing, or are we making this up?
It's a semi-real thing. I think it was a term in some kind of like pop culture thing, maybe some kind of sci-fi thing, and then scientists were like, that sounds cool as heck, and we're going to take that.
We can use that. Okay.
Exactly.
I do appreciate scientists' willingness to do stuff like that versus historians. It's like, well, when did the war begin? 1812? There we go. That's what we're calling it.
So a different way, like I said, so the cinder cone, shield volcano, and stratovolcanoes, those are classified based on how the actual structure is built. Another way to classify them is by something called the explosivity index, which is basically how much stuff do they throw when they erupt. And this is like with earthquakes. This goes from a scale of 0 to 10, but it's a logarithmic scale. So 2 is not half of the strength of a 4. It is 1% of the strength of a 4. So each number it goes up, it increases by 10 times. If that makes sense. So some volcanoes, like the Hawaiian Islands, don't really throw all that much stuff. They're very, like I said, they're very flowy. They're not the boom kind. So they have a volcanic explosivity index of 0.
Okay, and I
Some
assume 0 is like
yeah.
like there's no negative numbers when we're talking about this. 0
No.
is the minimum. Okay.
No. Some throw quite a lot, such as Mount St. Helens in 1980, which had an explosivity index of 5. So that's sort of the baseline. The most costly arguably economic disaster in the history of the United States. I think Katrina might rival that, but I don't know. I didn't look at the specific dollar amounts, but
right,
definitely
it's up. It's huge. It was a big problem.
Right. So that's a 5. And just for reference, Mount St. Helens eruption released about a third of a cubic mile. So that is a third of a mile by a third of a mile by a third of a mile cube of stuff. Ash, those volcanic bombs that I mentioned, which a third of a cubic mile doesn't sound like a lot.
Until you think
that that's just miles and miles and miles of ash raining down everywhere.
Yeah, that's nuts the way I'm thinking about a third of a mile. Like, the way I'm thinking about this is a high school track is like a quarter mile. You got to run around that thing 4 times in gym class.
Sure.
So like one time around that plus a little bit more stretched out into a line, that's a third of a mile, and you've got a cube of it all being that long. That's nuts. That's crazy.
Yep. Then there are supervolcanoes. Supervolcanoes have a minimum volcanic explosivity index of 8, which, as a reminder, is 1,000 times more than Mount St. Helens.
Oh, wow.
The baseline for this is that it releases at least 240 cubic miles of, it's called tephra, the various things that volcanoes throw. And just to sort of wrap your head around that, that is give or take the distance from Los Angeles to Las Vegas, or for people not in the United States, give or take from London to Paris as one side of the cube.
Okay. How common are these suckers?
More common than you would think.
Okay, tell me more.
So we'll get there in a little bit, but
okay.
You will not see a supervolcano when you come across one, because they are not mountains, they are craters. They explode so fully that they leave a crater behind.
That's amazing.
Yeah. The hotspot earlier that I said was a segue because Yellowstone, the most famous supervolcano around today, is on a hotspot. You can track where previous eruptions of the Yellowstone supervolcano were by looking at these previous craters that have been left behind. And Yellowstone is kind of I remember when I was in high school earth science, because New York is fortunate in that it's one of the few states that actually requires high school students to take earth science. But I remember we learned about it in earth science class. And I remember Yellowstone being like this boogeyman. Because it's like you hear about it and it's like, oh, it could technically erupt any time. It's overdue for an eruption, which like is not true.
Okay.
So I'm sure certain people might have heard that. That is not true.
Okay.
So it will. We have all sorts of sensors and things. I've been to Yellowstone with some of the people studying Yellowstone, and like there's sensors all over that place. If it's about to erupt, we would know.
How far in advance would we know?
I don't know, but it would be long enough to try and mitigate the damage. It would not be like apocalyptic, but it would be really bad.
Now looking forward to that. Okay, noted.
For example, especially when it comes to volcanoes in general, but especially supervolcanoes, because they throw up so much stuff, you have to really account for which direction is the prevailing wind in this region. Because most of the stuff is going to flow that way. And so most of the prevailing winds around where Yellowstone is in sort of northwest central North America, and it blows east mostly from there. So all of this stuff would probably blow all the way to like Chicago, St. Louis, that kind of area.
That would be problematic.
Yeah. So the last time that Yellowstone erupted in a super eruption. So all these features that you see in Yellowstone's very famous for like the hydrothermal springs and different geysers and things. All of that is because of this volcanic activity. So the last time that it super erupted was around 64,000 years ago. I'm sorry, 640,000 years ago. So it was a while, and that one wasn't even particularly big. The biggest one that we have like good record of everywhere is from around 2 million years ago, and it left a crater that is around 600 square miles.
Jeez. And
ash from this eruption can be found all the way from Southern California to St. Louis, Missouri.
Actually, I mean, I was kind of doubtful when we started talking about super volcanoes that this was actually a category that needed to be like named. But I mean, you've convinced me now. Like that's, at some point a difference in magnitude is a difference in kind. And this is very clearly a difference in magnitude.
Right. This is, and like I said, this is like an 8. I'd say that one's probably closer to a 9. I don't know that we've ever found good evidence for a 10. It's similar to like earthquakes. I don't know that I've ever heard of a 10 on the Richter scale earthquake.
But the scale goes up that height.
Theoretically, it's possible, but yeah. So the next bullet on my my notes here are: you do plan to have paleontology on your paleontology podcast, right? Which is a paraphrase from Jurassic Park. So volcanoes don't tend to leave very good fossils for obvious reasons. They tend to just burn stuff. There are some exceptions, but they're pretty few and far between.
That's wild if there's any exceptions to me, but okay.
Yeah, so some examples are just sort of off the top of my head. Very famously in Nebraska, there's a state park called the Ashfall Fossil Beds, where it was very far from a volcano, so it's not like, the lava poured around things and preserved them. Although I have heard of that happening like once or twice, finding some evidence of that. But much more commonly how it's found is the volcano is several dozens, potentially hundreds of miles away. And if the eruption's big enough, it will throw off enough ash to then bury things and kill things. But because they're being buried as they die, they get preserved as fossils. And that's what happened at Ashfall. So it's very famous for its rhinos. So there was just this herd of rhinos over the course of likely a good amount of time, because some of the bones look like, they have cancer and things, and different bone diseases because they've been breathing in all this ash for so long.
Wow, okay.
So this was a very slow raining death down from the heavens.
Question sort of on this track of things being preserved with volcanoes. Is it sort of like Pompeii, how there's things that have been preserved from, kind of that explosion?
These rhinos specifically, no. Pompeii was preserved, and it's called a pyroclastic flow.
Okay.
So that is there. It's very commonly, if you see any movie with a volcano in it, and you see people running away from like a big cloud of dust in a volcano, that's a pyroclastic flow. So it looks like it's just smoke, which is very misleading because people often are seen running in it and then escaping it somehow, which is just one of the dumbest things that any movie can possibly do, in my opinion. Because it's not just smoke. If you're around like a campfire and the smoke blows on you, you're uncomfortable, and maybe you feel a little bit of the warmth coming off the fire, but like you're fine. Pyroclastic flows, the smoke isn't smoke, it is ash. And it's not like campfire ash where you touch it and it just turns to like powder. This is microscopic shards of glass. That's what volcanic ash is. And so not
you don't
only
want
are
that.
you being surrounded by these shards of glass and breathing them in constantly, they're also several hundred degrees. Like they were literally just liquid molten rock. But, just because they're now solid doesn't mean that they're cold,
Right.
So these pyroclastic flows can be hundreds and hundreds of degrees, like up into the over 1,000 degrees.
Mm-hmm.
So it's not you will not be buried, or at least the being buried will not be the thing that kills you in a pyroclastic flow. But that's what happened in Pompeii, long story short. So those can preserve things very quickly, like Pompeii. And there's a handful of cases of things like that happening. I think there's, again, rhinos tend to get really caught up with volcano stuff. There's a good handful of different rhino specimens from various places around the world that have to do with volcanoes. But yeah, just in general, it's like, but especially like the lava. So for example, you're not going to get fossils in Hawaii's lava, the slow flowy lava, because even if something
burn everything,
exactly, you might potentially be able to see, oh, something was here, but we have no idea what it was. It just is somewhat different looking rock, but even still, that's fairly uncommon.
Mm-hmm.
And it's very strange because volcanoes are very commonly associated with the past. Like if you go and look at like paintings of dinosaurs and stuff, it's especially true with dinosaurs, but if you look at paintings of dinosaurs from like the 20s or 30s, they'll all have volcanoes that are constantly erupting in them. It's kind of a trope that everything to do with dinosaurs, there's also a volcano somewhere. So,
is that true?
Not particularly, not any more than it is now. Volcanoes are even today are extremely common. They don't always explode, which is why you don't hear about them.
Mm-hmm.
And especially if you talk about underwater volcanoes that just kind of do their thing. Yeah, there are literally volcanoes pretty much everywhere. And volcanoes, I think it's much more interesting to talk about volcanoes and how they impact life instead of like how they make fossils, directly. Because they affect life in kind of all the ways that you would think. We talked about the different element cycles, which in some ways is a positive. It gives, introduces various things that life needs back into the surface world. But obviously, most people think of volcanoes as negatively impacting life. And so all of the ways that it negatively impacts life are pretty much what you think. Burning stuff in the immediate surroundings, and the ash being pretty bad. However, it's a lot of things about the volcanoes are very subtle in how they are dangerous. Particularly when it comes to very long timescales.
What do you mean by long? Okay, so first of all, how long is long?
So now we segue into the part of the conversation where we talk about mass extinctions.
Oh, yeah. Okay, here we go. I'm into it.
We've covered 3.5, sort of, mass extinctions on this podcast in episodes 59, 72, 81, and 89. We've been going through all of the geologic periods in order, and so far we're through 3 of the big 5 mass extinctions. And the 0.5 is from a small one that only had to do with plants. And coincidentally, Mike, you were there for most of those. Do you remember me ever bringing up the word supervolcano?
It doesn't ring a bell. I'm sure you did.
That's a trick question, because I did not.
Okay. All right, that makes me feel way better. I felt so bad for a little bit there. We were talking about your bad memory at the beginning of this podcast, and I was like, oh no, he set me up and I got nothing.
No. So, none of them, none of the extinctions we've talked about, or the extinctions that we will talk about in the future, have ever been associated with a super volcano eruption. Because, yeah, they're bad in the fairly immediate area. Like, when Yellowstone erupts, or super erupts again, which, like, it will, like I said, not soon, but it will. It's a volcano. North America will have a really bad, probably year and a half, couple of years. But the rest of the world will be more or less fine.
So this is not a situation where, like, ash goes up in the sky and like blankets the earth and blocks out the sun for, for however long, on a global scale.
Not in a way that would cause a mass extinction.
Okay.
So there was an eruption of some volcano. I don't remember exactly. I want to say there was a very, very large eruption in, I think, 1915. Or I'm sorry, 1815. Somewhere in the Pacific. And it very famously caused the next year to be known as the year without a summer. Because the ash and certain volcanic gases as well block out sunlight, and that lowered global temperatures for about a year. So super volcanoes, yes, can have that kind of global impact, but it's like, yeah, things might be a little crummy. Like, so when, Yellowstone erupts, things in, Central Asia, might be a little colder, might be a little less sunlight, but it's not going to cause mass extinction. Things might struggle a little bit, but in general, most places will be fine.
Gotcha.
But something that listeners may have heard me mention, and or Mike may have heard me mention in some of those, are large igneous provinces.
I hope some listeners remember that, because I don't.
So, Mike, what is a province to you as someone who understands geography?
I mean, province, I always think of province in terms of like Canadian provinces, like the equivalent of states, just this, generally more political area of separation of things. It's an area of land, basically.
Right. Generally a fairly large area of land.
Yes, generally a state, again, for our American listeners, like a state kind of size level.
Or bigger. Canada has, I want to say, 13 provinces, and they are a larger country than we are.
Right.
Compared to 50 plus all of the different, imperialism that the United States has done overseas. So a generally large area of land, that is a province.
Right.
A large igneous province is a section of Earth that was, at some point in Earth's history, constantly erupting over the span of tens of thousands to a few million years.
What?
So remember earlier when I mentioned those volcanic fields?
Yeah.
Just an area of land where pretty much at any point, a vent spewing some lava could open up in that general area. Large igneous provinces are that, but provinces.
Good God.
Areas that are hundreds to potentially thousands of square miles.
I mean, this seems like the kind of thing that would make like life inhospitable for a really large, maybe not quite global, but for a really large segment of the planet.
Sometimes. We'll talk about it.
Okay.
So, these things, like you said, in this immediate area, in these, where this giant lava or volcanic field is, yeah, life's probably not doing great there because everything's erupting all the time.
Right.
But if you were, say there's a large igneous province going on, say, for example, in Australia, if you were just an animal or even a person, say, before the spread of like mass news, if you were a person just in North America and there was a large igneous province going on in Australia, you wouldn't really even know,
Wow. Okay.
But it's the fact that this goes on for tens of thousands to millions of years. And it's that buildup that becomes the problem. So the actual lava field itself probably doesn't even cause any real animals to go extinct, because for the most part, they can just kind of move to a slightly different area so they're not being drenched in lava all the time.
Right. The bigger problem is all the other effects.
Exactly. And the reason I said sometimes to why this would make life pretty inhospitable is because these are actually fairly frequent in Earth's history. There have been dozens of these over the course of Earth's history, including one as recent as 16 million years ago, right here in North America in the Pacific Northwest. And for example, my master's thesis, the site that I was working on took place not terribly long after that, around 10 million years ago, and things were pretty groovy. In North America at the time, North America was kind of actually doing super well around this time.
Mm-hmm.
But like I said, the danger comes from having all of these volcanoes going off for such a long period of time. And I'll put some links to various papers down the show notes that I kind of perused while I was doing a little bit of the research, because I was like, is there like an actual correlation between the amount of lava that these things gave off and mass extinctions? And it turns out there actually isn't. With a little bit of an exception.
So there's no correlation between the amount of lava and amount of death?
Right.
Okay.
Because so many other factors also play a role. Where the continents are, various climate things that are already going on before this, kind of thing happens.
Right.
How recently was the last mass extinction? How well is life doing? If life's already not doing great, this is, just another nail in the coffin.
Right.
And so, like I said, the big thing from these are not even all the ash. I kind of hyped up ash as one of the more dangerous parts of volcanoes, but when it comes to large igneous provinces, the big killer from these things is all the gases they sort of spew off, namely carbon dioxide and sulfur dioxide. Carbon dioxide, we don't have to talk about why that's not great in general when a lot of it gets put into the environment in a short amount of time. And sulfur dioxide makes acid rain.
Not the kind of thing that's, great for living beings.
No. And also, I put in the notes here, this is the 6th episode in a row where I've made a reference to how we're making the planet harder to live on with climate change. So election season's coming up. Please vote for pro-climate, elected officials, please. Thanks. So when these volcanic fields, these igneous provinces, are throwing off all this gas for this amount of time, it does some really funky stuff with Earth's chemistry. And spoilers, there is a large igneous province associated with 4 of the quote-unquote Big 5 mass extinction events. In the Devonian period, episode 72. The Permian period, episode 79. The Triassic period, episode eventually. And even the Cretaceous period, also episode eventually, with the one that killed off the dinosaurs. And I remember way back in episode 2, you can go listen back to that if you want to cringe a lot. Where
a while ago.
Yeah, where we talked about the dinosaurs and how they went extinct. And I remember blowing your mind with telling you that it wasn't just big asteroid hits Earth, everything dies. It's a lot more complicated than that. And one of the things that make it more complicated is that at the end of the Cretaceous, on top of the big asteroid hitting the planet, there was a large igneous province going on over in India, doing its thing.
Mm-hmm.
So 4 of the Big 5 have one of these associated with it. The only one that doesn't, or at least didn't, was the End Ordovician mass extinction, episode 59.
Oh.
And I say didn't because this year, in July of the year of our Lord 2022, there was a paper published suggesting evidence of one found in Iran. And
this seems like okay. So like, if one of these comes, it seems like it's real bad news for Earth. Like, is there evidence of like other ones of these that exist that like, And the moral of the story was everything was fine.
well, fine-ish. So
Okay.
you weren't here, I don't think, for the end Permian mass extinction episode.
Okay.
But that is the worst mass extinction. And it was very obviously, that's the one where I was like, except for this one, where when I said there wasn't a correlation between lava volume and amount of extinction, where this is clearly the largest large igneous province and also the worst mass extinction.
Yeah, okay.
So
that'll do it.
Well, actually, I'm looking at some different numbers now. It technically depends on how exactly you count it. There is one that is potentially quite a bit larger than this one, but that one also does have a mass extinction to it as well. Spoilers. That's the Triassic one. But we'll talk more about those in those respective episodes. But needless to say, it's really very suspicious that whenever there is a mass extinction, there is one of those things kind of around. And I thought of a very wonderful analogy when I was writing this script, very coffee induced. In that large igneous provinces truly are the Forrest Gump of geologic features.
That's a great way to put it.
They're
fantastic.
They're always around doing stuff at other times, but during major world events, they always kind of just show up.
I love it when Forrest Gump is used as an adjective.
Oh yeah, excellent movie. One of my favorite movies. And so, because like I said, they're fairly common. But when we have mass extinctions, there's always kind of one around. And just sort of thinking about it, I'm like, this kind of led me to one of two conclusions. One is that they are so common that if they're happening all the time, of course, there would be one when there is a mass extinction. The sort of a stopped clock is right twice a day sort of thing.
Right.
Which kind of makes sense, right? If something is always happening, you're not surprised when one happens. Or
okay.
The sort of alternative, and the one that I think most people sort of side with, is that they are necessary, or at least somewhat necessary, for large-scale mass extinctions to happen, but very rarely cause them in isolation by themselves. For example, like I said, we have one, arguably two mass extinctions that are directly attributed to pretty much nothing else besides a large igneous province. But when the world has some weird other stuff going on, and then a large igneous province shows up, that's when mass extinctions generally happen. So for the end Ordovician, the one that people didn't think there was one for, there was a lot of weird glaciation stuff going on. We did an episode about Snowball Earth at one point, and this is one of those times where extreme amounts of glaciers. But, like I said, there was just published evidence of one of these large igneous provinces further messing with the chemistry, specifically of the oceans at the time. With the end of the Cretaceous period, life might have already been doing not great because of these large igneous provinces, and then the asteroid hits, which obviously doesn't help.
Yeah, that seems like bad for the whole, life thing.
And so the two, like I said, that are fairly directly attributed to this is the end Permian, the worst mass extinction ever, once again, episode 89, and the end Triassic, which is mostly due to the rifting apart of Pangaea, which, as I said, when, tectonic plates move apart, that creates a giant string of volcanoes, like we see in the middle of the Atlantic today, like I mentioned. When Pangaea is rifting apart, that's all happening in the middle of Pangaea. So
and
we will discuss.
And all the land is concentrated around, all the lands together. So if something happens, that's
exactly. So we'll talk about that in a Triassic extinction episode coming soon to a podcast near you.
Jeez, I'm just imagining. Like now, I have the visual in my head now of just you have this just like center of Pangea, just like, by the way, you're going to hell.
If I'm breaking apart, you're coming with me.
Yeah, right. Exactly. That's so that actually makes sense as to why that it would be the worst mass extinction event.
So the end Permian is the worst one, and that's a bit before.
Oh, okay. So I assume this is one of the worst ones.
Yes, the Triassic is also pretty bad.
Gotcha. Okay.
But those are the two that are sort of directly attributed to pretty much nothing else besides the large igneous province.
Understood. Okay. And we have volcanoes, large igneous provinces, and a whole lot of death going on.
Exactly. And that is the happy note that we will be ending this episode on.
As we are wanting to do, ending on the happiest notes.
Yes. Volcanoes. I could spend several hours talking about volcanoes because they are so neat, even though that's not at all what I do. Either in my current job now or in like my own research stuff. But the reason why I was actually sort of inspired to do this episode was because this week in the labs that I set up at the university that I work at, they're learning about igneous rocks and volcanoes and stuff. So I got to play with some actual volcanic ash that one of our students back in the 90s collected from Mount Pinatubo. So we have several big jars of ash from that gigantic eruption. We have some ash and different rocks and stuff from Mount St. Helens from that eruption. So I got to put out all these various things for all of our students to look at and learn about and stuff. So I was like, volcanoes are pretty neat. We should do an episode about those.
I mean, so I don't know if anyone was able to hear as we were recording, but there was kind of a storm passing by when I was here. And I've always, ever since I was a little kid, just had a fascination with, storms and lightning and earthquakes and tornadoes, and, volcanoes are kind of right on there. Like all of just the extreme weather events of the earth. I remember, as I think I was in 4th or 5th grade, just being glued to the Weather Channel, watching as like Hurricane Katrina kind of rolled in, and just like, following that, not even after it had hit when it was a big deal, but just like as it was, in the ocean, in the Gulf, like gaining steam. I've always had a fascination with that stuff. And volcanoes, like you said, they don't happen. We haven't had too many huge explosions, during your and I lifetime, and, even fewer that have had a huge impact on people. Like the Hongatauga one, just was not near a whole lot of huge population centers, but
right.
I love those extreme weather events and extreme earth events that this planet can create.
Yeah, and it's that's usually the last lab that some of the teachers do for their first semester of intro geology, because for the most part, we have some majors in the class, but most of the class are not geology majors in college. It's mostly people like history majors and things that need to take their science credit.
Yep.
And so the thing that we leave them with is Earth is an amazing place that is also absolutely horrifying the more you learn about it. The last lab is about geohazards. So we learned about tsunamis, earthquakes, volcanoes, all of the geology related natural hazards.
Oh boy, Earth is amazing and also horrifying. So is this podcast, and that's where we will be ending everything today. This has been episode 92 of I Wish You Were Dead, a podcast about things that used to be alive. My name is Mike. That is Gavin. We hope to have Thea back soon, but we'll see all of you next week for an episode on the Adirondacks. Until then, take care, everybody.
This episode of I Wish You Were Dead was written by Gavin Davidson and hosted by Gavin Davidson, Mike Bryson, and Finella Campanino. It was sound edited and edited for YouTube by Gavin Davidson. Special thanks to former guests of the pod and to listeners like you.